Okay, so when you approach a problem, the first thing you really should do is assess what's going on. I recommend assessing the variables first. So we know we have variables on both sides. And remember when I say assess, look to make sure to see if there's a subtract or a negative sign or a positive sign in front. That sign goes with the number. So notice negative 4a, negative 3a. Well, negative 3a, if you look at a number line, negative 3 is larger, is a bigger number than negative 4. It's closer to 0. So I recommend moving. So add 4a to both sides. And then notice when you do that, negative 4a, so if we take negative 4 and we add 4, we're at 0, right? So that cancels, and that leaves 12 is equal to 4, negative 3, negative 3a plus 4a. In fact, we could write it down, I guess. Now you can combine terms. And in this step, by the time you get into an algebra class, it's probably okay with the teacher that those two you can add together, and that just leaves 1a, or just a. It's okay if you just put a. Well, now to cancel a number by itself, the opposite of adding 4 is subtracting 4. So I like to do this, because when you get in advanced math later, you're probably not going to do vertically, but if you prefer this, then do it that way. All right, 12 subtract 4 is 8. The 4 subtract 4 is 0, and 1a is just a. And then you can check your work. So 12 subtract 4 times 8 is equal to 4 minus 3 times 8. Well, let's see. 4 times 8 is 32. 12 subtract 32 looks like negative 20. 4 subtract 24 also is negative 20. So, but the key thing is pay attention to the variables. So let's come down and look at number 3. 5m. 5m is smaller than 6m. So to zero out a positive 5m, you're going to subtract 5m. And remember the teeter-totter effect. To keep a teeter-totter balanced, say you and a buddy are sitting on a teeter-totter and you both weigh the same. Well, if somebody jumps on this side, the teeter-totter is going to go down, but if the same weight is added here, it'll stay balanced. So whatever you're doing to this side, you've got to do that side. So now that leaves 6 is equal to 7. 6m subtract 5m is just m, or 1m. And then we just have to cancel that positive 7. So negative 1 is equal to m, and then we could try it out. 5 times negative 1 plus 6. Well, negative 5 plus 6 is 1. And then 7 plus 6 times negative 1. Well, 7 plus negative 6 is also 1. All right. Now we're going to come over here. And then this should be short. Assess what you're doing. Look at what we have. We have a positive x and a positive x, and a negative 1 and a negative 1. These are the same. They're out of order. They did the commutative property, but negative 1 plus x means negative 1 plus x. They just reverse the order. Same on both sides. So you wouldn't do any work. You would just say infinite solutions. And you're going to see on the answer key, whenever you see all real numbers or all reals, it means the same as infinite solutions. Right. Now look at what we have here. Oh, look at variables are the same. But constants, the numbers by themselves, are not the same. There's no work to show. Right away you know, well, if the 7s cancel each other, and they do, negative 8 does not equal negative 4. Right there, you could just say no solutions. And sometimes that's called the empty set, but I think it's safer to put no solutions. These funny brackets, it almost looks like the profile of somebody's face with a really sharp nose and a like big chin and big forehead. These are called solution set brackets. They tell the reader that you're saying, by the way, this is a solution set. So if you have a teacher that ever says solution set notation, that's what you're going to do. All right, that's it for this video.